Hi, this is Angela Tabafunda. Student number is 162-426, and I'm here to discuss about the G buffers and the deferred lighting on our challenge tree. So basically, we have G buffers, which enables us to sample from our scene and split it into textures. And here's what our light path looks like. Not successfully implemented, but the idea of a light path is that it allows us to calculate our our lighting per fragment that's going to be outputted on the scene. The final result for combining the light path with the default scene would look something like this, but not entirely right, because there's something wrong with the lighting paths that we have. So code-wise, our G-buffer fragment shader would look like this. Hold on a second. What? Wait, Wait a minute. So code-wise, the G-buffer fragment shader would look like this. This fragment shader basically splits our information and puts them into textures, which we'll use for our lighting calculation for the light path. So the light path shader would look like this. So you take in the textures from the G buffer in as parameters, and then you calculate light over here, and then you output it. So onto our main. So to do G buffers, you must create an FBO that has as many amount of color textures that you need. So in our case, we're having three color textures attached to our FBO because we're gonna need position, normal, and albedo for the color. So aside from the G buffer, we also create an FBO for the light path as well as another FBO for our final rendered scene. So we make our materials here. So we have a G buffer that uses our material that uses our G buffer shader, and an accumulation material that uses the light path shader, and as well as another material that does the compiled the compiled scene, which has the lighting and the default object. So onto the implementation of that into our main. It's over here. Yeah. So onto that. Here we have cases that determines which mode we are toggling on. So on the G buffer toggle that we had onto our program, it has this part of the code here. So this part of the code calls in the albedo texture in that certain FBO and outputs it. So if we want to see normals instead of the color, we would want to put 1 here, and the next time we compile it, we'll see normals outputting onto our screen instead. So moving on to that, here we have our light path toggle. So basically what this does is that we call in our buffer light function that binds the FBO for our light path and samples from it. And as it also outputs it into our screen as a full screen quad. A full screen quad basically. So this function looks like this one. Here we bind the scene for drawing, and then we pass in our uniforms. In our case, we pass in light variables, and then we bind our textures that we had from our gbuffer. And then we unbind the scene. So that's what it does in a nutshell. And then for our final deferred light toggle, we basically sample from our lighting path and then from our default path so that we can achieve our final lighted scene, which is not entirely correct since there's an error on the shader. So we call on to our composite, and basically what this composite shader does is that we bind our deferred light FBO and we sample from the two scenes that we want to combine both. In our case, it's the base and then the lighting. We pass in our material, our uniforms, and then we draw it as a quad, basically. And then that's about it in terms of deferred light and gbuffers in the code.